My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering in the Department of Information Technology. I am working as a professor in the series of video lectures of operating systems. Today, I am going to give the complete information of the memory management. See, last videos we explained about the paging concept. So that paging comes from this memory management. So memory, what is memory? How memory can be divided? What are the various allocation techniques? What are the key aspects of memory management? What are the main process involved in the memory management? What is contiguous memory allocation? What is non-contiguous memory allocation? That and all we will discuss in this video. Memory management in operating system is the process of controlling and coordinating the computers in the memory. It's a memory management. It is a process. It is the process of contiguous and non-contiguous and allocation of the memory to the processor. That all depends in this memory part. In this, that ensures that efficient proper allocation of the memory space in the running of the process. So the process there are various process, that is P1, so on, Pn process. Every process required a memory. Every process P1 required memory, process P2 required memory. That process, how the memory can be allocated to the every process. That can be responsible for the memory management. So memory management involves keep track of the memory usage and allocation of the memory process and reclaiming of the memory when it is no longer needed. So what is that allocation of the memory, and that memory cannot be no longer needed? Which process has required how much of memory? This is a crucial for preventing the data corruption. If not properly allocating the memory, if memory is not allocating properly, so what happened? Data could be corrupted, and corrupting the data. So it enabling efficient performing of multitasking and maximizing the system performance. That's to depend upon the memory management. To maximizing the system performance that is a very important and crucial part of this memory management technique. What is the use of memory management? The use of memory management is maximizing the system performance and enabling the efficient multitasking is also one of the important issue for managing the memory. That is a very crucial part for to climb the memory is the memory management process. Okay. Memory is a hardware component that is stores data. That contains the instruction and information temporarily and permanent for processing. It consists of an array of bytes of words, each with a memory having the allocation of the data, it having some address. Memory holds both input data and program instructions needed to CPU for executing the task. So memory holds the data, memory holds the information, memory processes the data. That data it's storing and processing and contains the information that everything having specific address. The address allocating. It allocates the address and it manages and stores and process that everything in the process of memory. It contains having its location, its allocation. So that's why memory having allocation strategies that also we will discuss in this video. What are the various memory allocation strategies? Memory works closely with the CPU to provide quick access to data being used. So how the memory can be accessed to storing that information and quick accessing that information into the monitor that can display to the user, that can be performed and processing, that everything should be managed in the techniques of memory management. that ensures efficient use of memory, and it supports for multi-programming. Actually, what are the key aspects of the memory management? Now, the main memory management key aspects are memory allocation, memory deallocation, tracking of memory usage, and memory protection. So, memory allocation, assigning the portion of memory to a process when it is need to execute, that is memory allocation. So, there is a CPU. In the CPU having the part of the memory unit. This memory unit having the process that is allocated to memory. So that is the when the process needs to execute in the memory, that is the strategy of memory allocation. Memory deallocation. Once the process of memory allocating to that CPU, it again deallocating. C means that releasing the memory occupied by process after has finishing this execution, then it is can be deallocated. Means that once process completed for the execution in the memory, it can be deallocated. Means that process is closed. So once memory is allocated to the process, it executes sometime. After that process completes that execution, it going to be deallocated. Then tracking of the memory usage, keeping and records of which memory location are in use and which are available, and keep tracking of the all information and tracking where the process is currently executing, it is executed or it is executing, it is completed the execution or in the middle of the execution. That can be tracking part. That can be tracking part can be managed by the tracking memory usage. Then it going to memory protection. So preventing the process from accessing or modifying and memory belonging to other process, that can be handling by the memory protection, that can be to secure to save that information for accessing and modifying, that can be take care of memory protection. So the key aspects of memory management are memory sharing. This is the one of the key aspect of memory management as sharing. So allowing multiple process to access the same memory region under controlled by the condition where the process can be sharing by the memory and process releasing by the memory, that can be a part of the memory sharing. Then memory sharing is the one of the key aspect of the memory management. There is a swapping, is a very important technique and phenomena in this memory management, that is called swapping. This between moving the process between main memory and secondary memory is a swapping. The swapping techniques are two techniques, that is swap out technique and swap in technique. So swap out and swap in techniques are two that can be involved in the primary memory to secondary memory. That information is swapped from main memory to secondary memory is swapped out, and again secondary memory to main memory it is in swapped in. It is recycling process that depends upon the information transmitting between the secondary memory to main memory. So that's a hierarchical structure we seen here. When going to swap out and swap in and memory sharing, these key techniques are happening in the memory management. It's involved and follow the specific hierarchical structure. That's first starting from the secondary device is that magnetic tapes. This is a secondary memory where the huge information which can be stored in the secondary memory. Then it is going to be optical disc, there where that information is stored in the disk, that whenever you want you can retrieve to data and access the data and performing and saving the data. That can again it goes and store the information in the secondary memory is in the form of optical discs and magnetic discs. This is also come to the secondary memory. That information can be stored in the magnetic disk is quietly different than the optical disc. Then the information is goes to the electrical disk, that is also the secondary memory. In the secondary memory, that is information is in the form of magnetic disk and optical disc. that and all secondary storage devices. Friends, the information is processing from bottom to top, means that from secondary storage memory to primary memory. So bottom to top, when you going to bottom to top, cost is increasing, and storage speed is decreasing, storage space is increasing, storage space increasing, storage space is increasing, storage space increasing. When you going to bottom to top, cost is decreasing, so that cost can be increased and storage space increase when it performing depend upon the registers and cache memory and main memory. So this is the main memory, means that it is the primary memory, cache memory is also primary memory, registers also primary memory. So cost is increasing when you going to from secondary memory to primary memory, cost is increasing, storage space is also increasing, and length and size of the device is also decreasing, so registers are high speed memory, it is a primary memory, internal part of the CPU. So cache memory is in between the registers and CPU. Cache memory is one of the memory which can allocate the data from the registers to main memory, that perform the cache memory. And main memory is a primary memory which is in between the secondary storage device to the primary storage devices. Magnetic disk and optical disks are secondary storage devices which can be transmitting the information from the secondary memory to the primary memory. So when you going to top to bottom, the device length is decreasing, size of the device is decreasing, and cost when you going to top to bottom, cost is increasing, storage space is increasing, when you going to top to bottom, storage space is increasing. So these are the hierarchy structure of the memory devices, and part of the memory where we discuss from the registers to magnetic tapes and magnetic tapes to registers, that is secondary memory to primary memory. Actually, from up to this is the secondary memory part and this is the primary memory part. So primary memory, once you get perform any task, any action into the computer, that can goes to the first primary memory. Then once you can save that information, that and all is going to store permanently in the secondary memory. The information is going from primary memory to secondary memory. Again, you can access the information. Again, it coming from secondary memory to primary memory. So this is the hierarchical structure of the memory management system. Actually, why is memory management is important? So efficiency is the first main principle of the memory management. Efficiency. Optimize the use of limited main memory, allowing multiple processes to run concurrently without significant performance of the degradation. That's main depends upon the efficiency. So efficiency is the main memory management. It is very important part of the issue. One of the issue. It's a key aspect. Is the one of the key aspect. It is efficiency. Memory management mainly depends on that efficiency. That every device having its own efficient. Like primary devices having its own efficient, secondary memory devices have its own efficient. Depend upon that efficiency, we provide that they provide the stability. Stability means prevent the process from interfering with each other memory space and reducing the risk of crashes and data corruption, and reducing the crashes and data corruptions, that and all depends on stability of the devices. This device's stability means it having its own performance, it's having its own capability of the device. It is a stability. So secondary memory devices having its own stability and primary memory devices have its own stability. It depends upon that process having management efficient and stability of the process. Then multitasking, the enable operating system to run multiple applications and simultaneously by managing memory allocation and deallocating. Means once process allocating to memory is allocating, that process removed from the memory is deallocating. They are not only one process, it performing the various process. This can be depends upon the multitasking scenario. That's to be depend upon the system performance. Proper memory management and contributes the overall system responsiveness and overall system speed. It depends on the system performance. So the techniques used in the memory management techniques are paging. Divide the memory into different size of blocks and chunks. It belongs to the pages and allocating into them into the process. The same thing in the segmentation. Divide the memory into logical segments based on the program structure, allowing to different protection levels. Segmentation and paging. And coming to virtual memory means it expands the memory apart from the size of the memory by using disk space. That's an extension of RAM is a virtual memory. It enabling larger programs to run that physical memory available in the random access memory. It expands the memory from the random access memory. It's the illusion of the memory. So that is a virtual memory. Virtual memory can perform with the concept of demand paging. So that we can discuss in next video lecture, the how virtual memory can be formed. Okay, this can be formed with the paging and segmentation and virtual memory. These are the memory management techniques. It follows because of efficiency and stability and increase the system performance. These can all depend upon the paging, segmentation, and virtual memory. Okay, that main memory, actually the main memory in the memory management having main memory is nothing known as a random access memory. Is a large array of bytes or words that computer processor uses to store the programs and data that are actively being and processed. That how that data can be actively being and processed depends upon the data information which can process of the random access memory to secondary memory, and data stores from secondary memory to random access memory means primary memory. That's a primary memory means exactly which it is as a random access memory. Computers and processor uses stored programs and data that are actively being processed in between the programs and data which can be in between the RAM and secondary memory. This memory is volatile, and meaning that all data is lost when the power is turned off. The stored information is lost in the primary memory. So that is a RAM is different and ROM is different. Both are coming to the memory management part in the primary memory. Both RAM and ROM both are primary memory. So when the power is turned off, the stored information is lost in the RAM. But ROM is when power is turned off, the stored information is not lost. That should be there in the ROM. That again that ROM giving to that information to RAM. So main memory is crucial for executing programs, and it depend upon the size and speed directly influence the performance of the system, and it can affect the system utilization. So that is depend upon the memory management. Actually, that memory management having two address spaces. One is the logical address. The second one is the physical address. Logical address, an address generated by the CPU is known as logical address. So this is known as the virtual address. Logical address and virtual address both are same. Logical address space can be defined as the size of the process. A logical address can be can be changed. Enter the program executing, the logical address keeps on changing and keeps on updating. The physical address refers to set of that actual address used by the memory hardware. So the hardware generated the physical address. So CPU generates the logical address. The actual address, the hardware giving the address, that is called physical address. A physical address is also called as the real address. It is generated by the physical address is generated by MMU, is called memory management unit, generates the physical address. The hardware generated the physical address. The physical component generate the physical address. That's why it is called physical address. The runtime mapping of virtual address. The runtime, when program is executing, that runtime, this virtual address is mapping. Unlikely virtual address, a physical address remains a constant. Keeps on virtual address is changing, keeps on physical address remains, it can be changing. So that logical address based on the physical address, memory information can be swapped out and swap in. This technique is called swapping. So swapping moves a process between main memory and secondary memory to manage the limited memory space. It allows multiple processes to run temporarily. Swapping is a lower priority process. So it's a lower priority process for higher priority ones. The swapping out of process resumes once it is loaded block. Transfer time depends on the amount of data swapped in and swapped in that can be takes place from the swapping. Swapping comes entirely from the virtual memory. So how this swap out and swap in? See the secondary memory. So secondary memory is there is a process 1, process 2 in secondary memory. The main memory, the operating system is resident part of the main memory. So that swapped out from the second main memory to secondary memory is the process is called swapped out, and the process is from secondary memory to main memory is called swap in. This is the process of swapping between secondary memory to main memory. So that's why here this figure is mainly the process of the swapping technique between the secondary memory to primary memory and primary memory to secondary memory. The data information is keeps on moving from secondary to primary and primary to secondary. The data can be exchanged between these two, this from secondary to primary and primary to secondary. So actually, how memory management techniques involved? So what are the various memory management techniques? The memory management techniques are two forms, that is classified as uniprogramming and multi-programming. Uniprogramming means only one program allocated to memory, that is uniprogramming. Multi-programming means several number of programs allocating to memory, and memory can be processed the information to all the process, that can be management, that everything can be process can be take care of the memory multi-programming. That multi-programming has divided into two types, contiguous allocation and non-contiguous allocation. The process of the memory can be allocating, can be depends upon continuously allocating by the different number of programs. By continuous allocation means a fixed length of allocation. Again, it is different from contiguous allocation. Single contiguous allocation and partitioned allocation. So that continuous allocation of the memory can be single part that can be decided as the single contiguous allocation. That continuous allocation divided into different partitions, that is called partitioned allocation. Non-contiguous memory allocation have again divided into two, paged memory management and segmented memory management. Paged memory management is that they depend upon paging technique. Segment memory management depend upon is the concept of segmentation. Divide the memory into different partitions is segmentation and fragmentation. Again, fragmentation has two types, internal fragmentation and external fragmentation, and that's and all having give the brief explanation. I will give the next video lecture of that process information. Okay. Memory can be divided into contiguous allocation and non-contiguous allocation as the first technique, allocation of memory. Then contiguous allocation is the memory allocation is a memory management method where each process is given a single or continuous blocks of memory. This means that all data for a process is stored and adjacent of the memory locations and keeps on allocating and adjusting, and each process given single or continuous blocks. That is a contiguous memory allocation. So the contiguous memory allocation I am going to explain with this diagram. So there is a process P1 and process P2 and process P3. These three processes allocating to a memory without a process. That's a process P1 allocated to block 2, process P2 allocated to block 3, process P3 allocated to block 4. This process of memory without process and memory with process P1 to block 2, P2 to block 3, P3 to block 4. This is a contiguous allocation. Contiguous. So memory with process is contiguous. Memory without process, after it becomes as a memory with process. That is totally depend upon contiguous memory allocation. So this contiguous memory allocation, a process P1 to block 2, P2 to block 3, P3 to block 4 is in the process of continuous allocation of the memory that is involved in the contiguous. Okay, coming to non-contiguous process allocation. Non-contiguous process allocation involved paging, segmentation, fragmentation. That's all involved non-contiguous memory allocation. So this method allows non-contiguous allocation can be broken into small parts which are placed in different and non-adjacent memory location. This technique is called non-contiguous memory allocation, includes as a paging and segmentation. Paging means the process is divided into fixed size blocks. Memory can be divided into fixed size blocks is called pages, and memory is divided into blocks of same size is called frames. The operating system keeps a page table or to map the page table to logical pages to the physical frames. That pages to frames, and then it can be each page is mapping to frames that called physical frames. That is different from the segmentation. This process is divided into segment of varying size, such as code, data, stack, that all. So actually, I'm explaining the here as a with the pictorial representation of the memory can be divided into different partitions, like this called become pages and the frames, and page size and frame size should be the same. And also I am not depends upon the equal partitions. I am going to divide the memory into segments, like here as a code as one block, as a data is one block, as a stock is one block. Like these are called segments. Divide the memory into as a partitions like data, stack, and code, and these called the segments. So equal size partitions are called as the pages. Okay, coming to the non-contiguous memory allocation is called the fragmentation. Fragmentation is defined when the process is loaded and removed after execution from memory. It creates smaller free hole. Fragmentation, that hole cannot be assigned to new process. Okay, this hole can students, from memory it creates a small hole. These holes cannot be assigned to new process because holes are not combined or do not fulfill the memory requirements of the process. If the fulfillment of the requirements of the process in the operating system, the fragmentation can be again divided into two types of fragmentations. That is a internal fragmentation and external fragmentation. Internal fragmentation is the fixed-sized partitions, fixed-size memory blocks allocated to process larger than needed. So it's leaving unused space within allocating to the block. For example, internal fragmentation process needs 2 MB of memory but is allocated to 3 MB of memory. 1 MB of memory is wasted. That is called internal fragmentation. Suppose is a this is a memory. So here it is 3 MB of memory and 4 MB of memory. Now 2 MB of memory process came. So the process size is 2 MB of memory. Now 2 MB of memory I am allocated to this partition, first partition. So first partition size is 3 MB. So 2 MB process is allocated, 1 MB process is wasted. This 1 MB of process is called internal fragmentation. So what is the allocating of size of the memory block and the process size is smaller, that remaining wastage of the space in between that is called the internal fragmentation. So external fragmentation occurs when the free memory is scattered in the small blocks across the system, that making it impossible to allocate to large contiguous block to a process. Suppose the next block is 4 MB. Now 5 MB of process came. Now 5 MB of process allocated to 4 MB. So it is size is 4 MB. Now 1 MB is expands. Extra memory it takes. That extra memory making to allocate that extra memory, that block is the free of memory is not enough. The free of memory is not sufficient. That is expands that memory. So 1 MB of memory is expands. That is called external fragmentation. External fragmentation. Okay. Coming to allocation strategies. Efficient memory allocation is essential for optimal performance. There are several strategies for allocating the memory blocks. Those are fixed partition allocation and dynamic partition allocation. Fixed partition allocation, memory is divided into fixed size partitions, fixed size block. Each partition can hold one process. The operating system keep track of free occupied partition using the partition table, that fixed size partitions into fixed size partition. But in the dynamic size partitions is coming variable sized partition is nothing but a dynamic size partitions. Dynamic size partition depend upon the size of the process. Depends. Suppose the process size is 5 MB, the memory is allocated dynamically 5 MB. The process size is 10 MB, the memory size is allocated dynamically 10 MB. It expands depends upon the process when the process comes. So this helps to the avoid wastage of memory, but can result in the fragmentation. This dynamic partition allocation suffers from the fragmentation. But fixed size partition, it's a free of the occupied partition using the partition table. Dynamic partition can leads to the fragmentation. So memory allocation strategies are two: fixed partition allocation and dynamic partition allocation. Fixed partition allocation keeps occupying the partition using the partitioning table. Dynamic partition is wastage of memory, but can result in the depend upon the fragmentation is the problem in the dynamic partition. Okay, finally, memory allocation strategies. See, memory allocation strategies depend upon the placement algorithms. When allocating memory, the operating system uses placement algorithms to decide which free block should be assigned to a process. So which is the free block? So that block should be allocated. So first in, first out. This not first in, first out. As per the first in, first out scheduling algorithm, how it is like, the similar fashion here, first fit algorithm is there. This is one of the placement algorithm. It allocates the first available partition to large enough to hold the process. Suppose there is a memory. Now there is a resident of the operating system in the primary memory. So first the memory can be divided into 5 MB, and next is 6 MB, next is 7 MB, then again 4 MB. This is the size of the partition. Now I got 4 MB of the process, I got 5 MB of process, I got 2 MB of process. So now I am going to allocate 4 MB of process to 5 MB, 5 MB to 6 MB, 2 to 7. As first, whatever comes first, that I am allocated to first of that size partitions. This is called first fit. Which one is come first, that I am going to allocate into the as per the order, as per the size of the partitions, as per the order, whoever comes first, that I am going to allocate that. That is called first fit. Now I'm discuss about the best fit. Best fit is the allocates the smallest available partition that fits the process, reducing the wasting space. That is the best fit. Suppose 2. Now 2 process is there, that should be allocated to which is the smaller 4, that is suitable to 2. Now which is 5. So 5 is allocated to 5 as the first. Now that is the best. For 5 is there 5 MB of process. That 5 MB of process allocated to 5 MB of storage location. So that is the best fit of that process. Now 4 is there, already 4 is the allocated. Now if I am using 4, actually here 4 to reduce the space. So 4 is allocated to 4. That is the best fit. So worst fit means allocate the largest available partition from the largest remaining space of the partition. Now I allocated 2 to 7. This is the worst fit. So process size is 2 MB. Here maximum is 7. Now I am going to allocate 2 MB of process to 7 MB of partition is the worst fit. So that type of partition cannot be useful, but its system can be going to degrade the performance. To increase the performance, best fit is the good approach. To degrade the performance, worst fit is the approach. Okay, coming to next fit, similar to the first fit, but starts searching for free memory. So first fit is almost similar than next fit. It always search for the free memory. If free memory is there, that size of the process allocated to that size of the block. So this is the next fit. So next fit is the last allocation strategy. So we are seeing this first fit, best fit, and worst fit, and next fit. These are the placement algorithms of the memory management. In scheduling also, process scheduling also, first come first serve, shortest job first, round robin, priority scheduling, non-priority, preemptive scheduling. Those all we seen. Those are scheduling algorithms. Similarly, here memory management algorithms are placement algorithms such as first fit, best fit, worst fit, next fit, and these are the placement algorithms. Okay, students, this information I gathered from the book of this concept of memory management, Abraham Silbert's P. Galvin book. The title of the book, Operating System Principles, Wiley Student Edition, Publishers, 2010. And also I am also referred the second book, that the author of book William Stallings, and title of the book, Operating Systems, Internal Designs and Principles, Pearson Education, Publishers, 6th edition, 2002. Okay, students, this video this video lecture I giving the complete information of the memory management techniques and memory management allocation techniques. What is memory management? Types of memory management: contiguous allocation, non-contiguous allocation, partition, and then fixed partition and dynamic partitions, placement algorithms, first fit, best fit, next fit, all we seen in this video lecture. Thank you, students. Thank you for watching my video lectures. This video lecture is completely on memory management. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.